Everybody's coming in. Hello, hello, everybody. Welcome, welcome, welcome. Let's give people a minute before I start babbling, because then I don't have to say everything twice. Coming to you live from Geneva. If you're realizing, if you're seeing my new background and this sort of big hair because it's so humid and it's rained a lot here. So I'm wearing a scan pro, is what we call it. Welcome, everybody. I am so excited to have you here today. So Hildegunn has been here plenty of times, and Ben has been here even more. And so every now and then I get to persuade Ben to come talk about all the amazing things that he thinks about. And now today he's asking the mother of all questions, and I hope he's going to say yes to the answer, that the answer is yes, yes, yes. So welcome, everybody. If this is your first time at the TPR Forum, you are in luck, because you'll get to hear Ben, who is my co-founder here at the TPR Forum, come talk about his research. And he's so smart. He's not only super intelligent and a modeler, but he's also smart, which means asking smart questions. And Hildegunn Nordas is also coming in. She's at the airport. So we're hoping that she's connecting any second now. But if this is your first stop at the TPR Forum, then you'll see that we have a bridge here, and our goal is to bridge the gap between policymakers and researchers. We run a monthly webinar, and all of them are recorded and on the website. And we try to collect people across all disciplines and forums to have interesting discussions regarding trade policy. And today is, as I said, the mother of all questions. So let's see. Can you guys do me a huge favor and start posting in the chat where you're coming in from? So today I happen to be at the WTO in Geneva, and we'd love to hear where you're coming in from, and also get started on the chat box for questions, because one thing that always happens is that we run out of time, and that's going to happen today too with all your questions. So get ready. But without further ado, Ben, I think we should get you started. What do you think? Welcome.
Sounds good to me.
Welcome to the TPR Forum, Ben.
Yeah, thanks. First time.
Yeah, not even as a speaker the first time.
No,
so you're
but
not even tricking me on
it's
that.
nice to be here in a different capacity. And, that was a great introduction to the forum. Oh, I think I put the wrong slides up. Hang on.
No, this is the right one.
Oh, this is?
Well, actually, it's the host slide, but not the speaker slide. Yes, there you go.
Share. Okay, this is the one that we want. Okay, there we go. So it's great to be here. Thanks everyone for joining us. Hannah's given me a great introduction, and I've done the same thing again. Hang on. Let me get my share right.
This is usually me doing this. I see some really good friends in the audience, and some of our advisors. Barbara Fatwa is here, for example. Some of our really good friends say hi here, because otherwise we won't see you. Good to see you all. Go ahead, Ben.
Thanks, Hannah. So yeah, welcome everyone. Thanks for joining. Hannah said this is a big question, so I've got a tough job now. I've actually got to live up to that introduction, which is always the hard part. So my question that I'm trying to answer is, how useful are quantitative trade models for policy analysis? Before I get into the presentation, in case you have to drop off the webinar or anything, let me give you a few takeaways. So, what I'm trying to do is to answer a question that is really unfair, but it's a question that I get asked by policymakers all the time. Policymakers interpret the results of trade models in terms of will, whereas we economists always think of them in terms of would. So comparing a would with a will is not entirely fair, but I try to do it anyway, because people ask the question and I'd like to be able to give them some kind of answer. So when we're running this kind of test, comparing what a model spits out with what we actually see in reality, we need to do at least two things. We need to account for uncertainty, the fact that in the model we're using all these parameters that are noisily estimated. So we need to account for what difference that makes to our results. And then we need to also account for other determinants of changes in trade. We can't just compare the raw outputs of the model with what we observe, because the model is capturing a change in one factor only. So what I do is run a model a whole bunch of times for changes in trade based on a counterfactual of tariffs between 2017 and 2018. So just a single year looking at global changes in tariffs. Then I go through a number of steps to try and compare those results with what we actually see in the world between 2017 and 2018 in terms of the observed changes in trade. The unconditional correlations are actually a bit better than you might expect based on previous work, at least at a disaggregated level. But I think conditional correlations, that is to say where we control for a whole bunch of other stuff, are actually more informative. And then using PPML rather than OLS makes them even more informative than that. So shortcut to the results, all but one sector shows a statistically significant association between counterfactual and observed trade changes with the expected positive coefficient. So in all but one case, we're finding that what the model outputs is a statistically significant predictor of what we see in practice. So that's a big result. That's telling us that the model is doing something useful. Then even stronger than that, in about a third of sectors, just over a third of sectors, we see that we can't reject a one-to-one relationship between what the model says and what we see in reality after we control for all of these other factors. So that's a really strong result. The one-to-one relationship is probably even stronger than we would expect. So it's good news. You know, to answer Hannah's question, my answer is kind of a yes, that we can, thank God, use these models for policy. What I am going to say, though, is that I think the new generation of models, which is what I use, is maybe a little easier than CGE, that is to say GTAP-style CGE, for doing this kind of analysis. It's a lot more transparent, and it allows us to capture important features of the data without a lot of the complexity of GTAP-type models. So let me get into the presentation. I'm going to briefly give a motivation. I'll tell you about my model, which is the Caliendo and Paro 2015 model. I'll then talk to you about how I set up the test. So the test between counterfactual predictions from the model, how well do they predict observed changes in trade. I'll then give you the results and the implications, and I'll briefly wrap up at the end before we go into Q&A. Okay, so as I said at the outset, I mean, we use these things a lot in policy settings, but you know, to answer questions like, what will be the impact of a trade agreement if we sign it between two new parties? What would be the impact of a reduction in tariffs? What would be the impact of a change in services policies? But there's a big problem. We as economists always ask a would question. So it's a counterfactual. How would the world look if we changed one thing and kept everything else constant? That is to say, we keep technology, tastes, preferences, all these sorts of things constant. But policymakers don't think like that. At least most of them don't. They think in terms of a will. If I sign a trade agreement with my buddy, how much will trade flows increase? So they're asking what will happen in a concrete case in a particular outcome. They tend to think more about forecasts or predictions, whereas we think about counterfactuals. So in a sense, comparing a trade model with reality is a really unfair thing to do, because you never observe the counterfactual. You observe something quite different, where a whole bunch of factors produce the observed change. But what I'm trying to do in this paper is see how well the predictions of the model compare with observation to try and answer this question policymakers have, and then give some sort of feel for what proportion of observed changes the model accounts for. So CGE models have been used a lot since the 1990s to analyze these sorts of trade policy questions. I actually don't use a traditional CGE, GTAP style model. I use one of the new generation models. I put up a bunch of reasons on the slide as to why I think these models are preferable. They're not as widely used yet in policy settings, but people are starting to use them to answer important policy questions. So I've got a paper using this model on trade facilitation. Someone else has got a paper on the US-China trade war. There are papers on trade agreements, all these sorts of things. But basically, these models are a bit simpler. They have far fewer parameters. They're a lot more transparent, and you can use them with publicly available data. And of course, you don't need to go and do a special training course at one or two places around the world to use these sorts of models. They use standard theory that you learn in any graduate international trade class. So my model tests how closely one of this new generation of models, Caliendo and Paro 2015, produces counterfactual trade flows that match observations when we have known tariff changes. That is to say, we've already observed the tariff changes. There's only a small literature that tries to do stuff like this. Some is on the performance of GTAP style models, and the older contributions to this literature, so sort of going back 15 years or so, tend to suggest that they don't do a great job of matching reality. But there are some newer contributions using the new generation of models and much more sophisticated statistical tests that suggest that the new models actually do a pretty good job of matching reality. So what I'm trying to do is to fit somewhere in between. I'm testing a new generation model, but I'm doing it in a relatively simple way that I'm hoping any applied researcher can replicate using their own model. So speaking of the model, let me tell you about it. The Caliendo-Paro model 2015, it's a multi-sector Ricardian model. I'm not going to go through any of the algebra behind it. You can read the original paper. It's taught in a lot of trade classes these days. Like any model, it's got a bunch of assumptions on the consumption side. They're all pretty standard and very simple and transparent. It's got a bunch of assumptions on the production side, also very simple and transparent. What it does that I think is interesting and useful is that it accounts for both reallocations across sectors, taking account of the fact that sectors use each other's output to produce their own goods and services. And it also accounts for reallocations across countries, taking account of things like changes in tariff revenue and all these sorts of things that we can be interested in from a policy perspective. So the assumptions behind it are pretty simple, much simpler than you find in a GTAP style model. There's only one parameter per sector. A GTAP style model can have thousands of parameters, and you can estimate the parameters directly from the same data that you use to power the model. You can use a whole bunch of publicly available data to power the model equally. So, and a big bonus of this model for me is that trade is determined by structural gravity. It's not the most familiar type of structural gravity model, but it still fits into this context that we all know very well and which we know explains observation very closely. The original application of this model is NAFTA, and the authors, of course, very transparently make their code and data available. It's not particularly easy to work with. Here I want to advertise something that makes life much easier and reduces the barriers to getting into this sort of work very substantially. This great guy, Paolo Felipe, he doesn't advertise this. He hasn't published a paper, but he's made a beautiful R package implementing this model. It's got nice, clear instructions. You can format the data. If I can do it, you guys can do it. And it enables you to solve the model very quickly and to put it into your R code to do all sorts of interesting things with it. I use it with a multi-region input-output table from the Asian Development Bank. You can use it with any multi-region input-output table. Okay, let's go on to the next slide. Okay, so setting up the test, I've got 3 questions. One is that I want to know how uncertain model counterfactuals are, given that we've got to estimate these trade elasticities noisily from the data. Second question, for observed tariff changes, are counterfactual trade changes a statistically significant predictor of observed trade changes? I'm going to interpret that. If the answer to that question is yes, then I'm going to interpret that as showing that at least this quantitative trade model can be useful for policy analysis because it's got a pretty good match between what the model says and what we observe. Then a tougher question, for observed tariff changes, do counterfactual trade changes display a one-to-one association with observed trade changes? That's a much tougher test. If it's a one-to-one association, that means we've got a really close mapping between what the model is spitting out and what we're observing in reality. So if the answer to that question is yes, then we can definitely conclude that this model is really useful for policy analysis. My value added compared to the existing literature is that I do a few things differently. I control for factors outside the model. A lot of the literature on GTAP has been criticized for not doing that. I use a regression-based approach rather than simple correlations. And my approach is very simple. So anyone out there can replicate this approach with their favorite model. There's a great paper out there by Adao et al., which assesses the performance of a recent quantitative trade model using the US-China trade war as an example, and it finds a very encouraging result. It's a fantastic paper, but it's very, very complex. And I don't have the feeling that an applied researcher could just go out and replicate it with their own model. So what I want to do is to try and get maybe some part of the information that they have, but in a much simpler way that anyone can replicate. Then I'm also considering tariff changes globally across a single year, not a big change like signing a trade agreement. So I go through a few steps to set up the test. I estimate trade elasticities using the model itself for goods and services. I run the model 250 times to try and quantify the effect of uncertainty. So I'm using the same tariffs each time, but slightly different trade elasticities drawn from the sampling distribution of the data. I then compute the mean of those 250 counterfactual results, and I say that that is the expected value of the change in trade flows given observed changes in tariffs. I then use descriptive statistics like some of the GTAP literature to assess model performance in a way that's comparable, but using unconditional correlations. And then finally, I use a regression model to control for other influences. So first results, uncertainty, at least from the trade elasticities, doesn't make a big difference to how we interpret results. I run the simulation 250 times. It allows me to estimate 95% confidence intervals for changes in trade, or actually I report it using the value of trade. And the mean confidence interval is 0.9% of the trade value. So that's very, very narrow. We're getting down to less than 1%. So plus or minus 0.5%. The median is only 0.4%, so plus or minus 0.2%. So even with the uncertainty in the trade elasticity estimates, we're not getting a lot of uncertainty in terms of what the model puts out, at least in terms of the mean and median. There are some extreme values where there's a lot more uncertainty, but they're very small in number. So that's a very good result. Again, can we use this model for policy? You know, I think this is the first result that says we can, because it's not so uncertain that we can't get anything out of it. The only caveat is that my application only looks at uncertainty in the trade elasticities. If you were doing something like estimating the impact of services policies, maybe estimating the impact of a trade agreement, you would have uncertainty coming from a bunch of other estimates. So that would increase the size of the confidence intervals, and you'd need to go back and revisit this result. Okay, so correlation-based performance. It looks a little bit like the previous literature. The previous literature always does it on the basis of aggregate pair trade flow. That is to say, total trade between the US and Canada, total trade between Australia and New Zealand, total trade between Norway and Sweden, to be inclusive of my friends here on the webinar. The pair results are not great. The correlation has the wrong sign and it's very close to zero. But when I go down to a disaggregated level, it actually gets much better. Disaggregated level, of course, has a lot more data. So the correlation is richer in terms of what it produces. And I get a correlation coefficient of about 0.2. So it's not particularly strong. But when you think that tariffs are only one thing that's influencing a change in trade over a single year, 0.2 is actually not bad. And it's a lot stronger than is reported in the previous literature. So it's a weak correlation. But it's definitely significant, and it's a little stronger than you might think just based on the GTAP literature. Okay, regression-based performance. I wanted to show you this visually. I've done this using OLS. I'm going to present some more results on the next slide using PPML. But a neat thing about OLS is that you can present the results of a regression controlling for fixed effects by importer sector and exporter sector, purely graphically using the Frisch-Wahl-Lavelle theorem. So I explain how I do that. It involves running 3 regressions where you control for things in each regression, and you can then plot the residuals from the 2 regressions against each other. But what you can see there is actually a pretty nice relationship. There's a strong positive relationship between the simulated change in trade on the x-axis and the observed change in trade on the y-axis. I find an estimated coefficient of about 0.25. This is in logs. So that doesn't suggest a one-to-one relationship. It suggests a less than one-to-one relationship, and an R-squared of about 0.12. It's statistically significant at the 1% level, even when I adjust for clustering and all those kinds of nice things. But this is a first result that again suggests that we've got a statistically significant relationship between what the model is saying at a disaggregated level and what we're observing in reality, again, at a disaggregated level. The R squared of 0.12 is interesting. That's based on the residuals. So after controlling for all these other effects. So it's really what you would call a semi-partial R squared in a regression. It's telling me the amount of variation in observed trade flows that is accounted for by the model after controlling for all sorts of other impacts on observed trade flows. So tariffs, and as they're expressed through the model, are accounting for about 10% of what's going on in the change in observed trade flows in a year. And I've got to say, that doesn't sound too bad to me. You might think that we would want a model to account for a lot more than 10%. But when we think that a model is only capturing changes in tariffs, and over a single year, tariffs don't change that much compared to a whole bunch of other things, preferences, technology, non-tariff barriers, all these sorts of things. That probably sounds about right to me. So as a bit of a reality check, I think that tells us that one thing we've got to keep in mind is that tariffs are only one thing that's going on in the world in a given year. Okay, so the results that I prefer are not the ones I just showed you. I think those ones are useful for getting a first look at the data. The ones I really like are the PPML results. I'm not going to get into technical details, but there's a nice literature showing that when you've got a log linearized model with heteroscedasticity, again, if the term's not familiar, it's just an econometric term saying that you've got a different variance as you go across different values of trade flows in the error term. OLS can give you inconsistent results. This other estimator, PPML, it's easy to implement and it is robust to this sort of problem. And there's a whole literature on that in the context of gravity models. So I run a PPML regression and I actually get a much better result. The estimated coefficient for OLS was 0.25. For PPML, it's 0.64. So that's much higher. And again, that's a statistically significant association between what the model says and what I see in reality. And that's at the 1% level, again, adjusting for clustering and all that nice stuff. So to answer my question, is the model useful for policy analysis? Well, I said I was going to base that judgment in part on whether or not it's a statistically significant predictor. Clearly, the evidence is that it is. The second part of my question was to look at whether or not there's a one-to-one relationship between what the model says and what we observe. The PPML regression, putting all of the sectors together, doesn't support that. It rejects that hypothesis even at the 10% level. So what I can do, though, is rerun the regression sector by sector, again, clustering, in this case, by pair. I think it's informative to do that because we could conceivably have differences in performance in the model from one sector to another. And in this case, the results are actually really nice. So 34 out of 35 sectors have a positive and 1% statistically significant coefficient. So first part of my question, is the model producing results that are statistically significant predictors of observed trade flows? Absolutely. So is it useful in a statistical sense? The answer is a very strong yes. Is it useful in a quantitative sense, in the sense that the numbers display a one-to-one relationship? For about a third of sectors, I don't reject that hypothesis at the 1% level. If I do it at 10% or 5%, I reject a little more frequently. But that's pretty good evidence that at least for some sectors, we are getting this really nice one-to-one relationship that I suggested was actually the harder part of the test. So what I conclude from this is that counterfactual trade changes from the model are a strong predictor of observed trade changes at a disaggregated level. That is to say, exports of agricultural products from Australia to New Zealand. So looking at pairs of countries by sector. However, controlling for other sources of variation is absolutely vital when we're looking at comparing the output of the model with what we observe in reality. So it provides a bit of a gloss on some of the previous literature looking at GTAP style models where they didn't control for external influences in that way. So my answer is a pretty strong but not unequivocal yes, that these models, or at least the one that I'm looking at, are pretty useful for informing policy discussions. So let me wrap up before handing over to Hildegunn. Let me just remind you of the key points from the presentation. First one is that the question I'm asking in the paper is a little bit unfair. I'm comparing a will with a would, so a counterfactual change with an observed change. But I'm doing that for the very good reason that I think every time I presented the results of a quantitative trade model to policymakers, and I should say this is true whether it's a complex model like the one I'm using here, or whether it's just a gravity model, so, you know, much simpler structure, they always ask, how does it compare to reality? How well does it predict what I actually see? So I'm trying to answer a policy relevant question. In answering the question, I think we need to do at least two things. We need to account for uncertainty in the parameters that we use to power the model. And we can do that by repeatedly simulating the model with different draws from the sampling distribution. And then we need to account for other determinants of changes in trade, even over a short period like the one I'm using here. So when I go through and do that, and I compare model counterfactuals for an observed tariff change between 2017 and 2018, so comparing the counterfactual trade change from the model with observed trade changes between 2017 and 2018, I find that the unconditional correlation is not particularly strong, but it's better than you would expect based on what's been reported in the previous literature. However, conditional correlations, that is to say regression model with fixed effects, are a lot more informative, and that's particularly true when we use PPML rather than OLS. In all but one sector, I find that the model is a statistically significant predictor of observed trade flows with a coefficient that has the right sign. And around 1/3 of sectors have an even stronger result where they don't reject the existence of a one-to-one relationship after controlling for other factors. That is to say that observed trade changes have a one-to-one relationship with what the model is saying after we account for stuff that the model is not accounting for. So my takeaway is that the new generation trade models are much simpler than GTAP style models, but nonetheless, they're obviously capturing some very important aspects of what's going on in the real world. So that to me is a great combination. Simplicity and transparency, but a close relationship to data. That I think means that at least for the model that I'm looking at here, we can give a pretty good yes to the question, thank God, as Hannah said. That quantitative trade models that we actually use are informative for policy discussions. So thanks everyone for your attention, and let me hand back to Hannah.
Phew, that was, well, a brilliant presentation, but I'm also so relieved to hear that. And also, like the device goes, less is more, as what it seems to be. Yeah. Right? This is super interesting. And I'm so glad that we now have our discussant. And it's not me. She just borrowed my Zoom link.
Oh, yeah. She's masquerading. I like it.
And so since we have almost done we're not up to 250 variations or of the forum, but almost we're getting there. And so today we have speakers coming in from the airport and another one who's at the WDO. And so without further ado, we're going to let Hildegunn in here. And let me just remind everybody now, again, we always run out of time. So start using the chat box, get your questions in, and don't blame me otherwise if you don't get your questions in. Go ahead, Hildegunn. We're so happy to have you here today.
Thank you so much. I hope you can hear me. As you said, I'm at the airport, and actually I cannot share my screen, but if you allow me to do that, I'll bring up my presentation. If not, I guess you have it.
Oh, sorry. Yeah, you should be able to share now.
Okay, let me see. Yeah. Let's see. Let me see if I can find it. It's a lot of strange things here. Or maybe you can share it because it's
Is it still not working? Let me there's another setting that I can there we go. We can see it now.
yeah, but it's just to find the presentation seems to be an issue.
In the meantime, Hildegunn, let me just ask Ben an important question while you find this. Ben, were you surprised by the results?
So
my presentation up. I sent it to you yesterday, so for today.
So I can't, Hannah, can you put it up while I'm speaking? I can't do both simultaneously.
Okay, now it works.
So, just to answer the question, you know, was I surprised by the results? I was really, like you, Hannah, if I'm honest, I was really hopeful that it was going to come out to say that this stuff that I've been doing for years is not actually a total waste of time. I was a little surprised because the model that I use has been examined kind of tangentially in one of the GTAP papers. So it's a Kehoe et al. Paper from 2007. And, you know, they report results that are not particularly encouraging, a bit better than GTAP, but still not great. And, you know, I found the reason for that. It's that they look at a pair aggregation. And when you look at it at a disaggregated level, you've got a lot more data. The correlation's more informative and you find a better result. So that actually kind of made sense to me. But, you know, I was hopeful because the more recent paper using statistical methods, you know, a lot more sophisticated than just a correlation, this Adao et al. Paper that I think is fantastic work, but a little hard to replicate. You know, they found quite a close relationship between a related model for the and welfare results from the US-China trade war. So I was pretty encouraged by that. So I was hopeful that I was going to get something similar. But obviously, when you do a piece of research like this, you actually never know. And I should say, so there was a question in the chat as to whether or not this is published. No, it's not published yet. This is work in progress. So, you know, given how long journals take, you know, look for it in a journal in 18 months' time. But I'll probably try and get a working paper out in the next month or two. So anyway, over to you guys now.
Also, just before I let Hildegunn in, I'm just going to let everybody know that you don't have to worry about taking notes and all of that. We will post the presentations as well as the recording on the website. So just kick back, relax, and ask your questions. Spend your time on that. Go ahead, Hildegunn. Thank you.
Okay, so you can see my screen now, yeah. The presentation. Okay, so thank you for having me. And it was really a nice and competently done paper. And I don't have very much to say about the technical kind of proficiency here. And let me just reiterate what Ben just said about PPML. I guess you've read Jutta Jottov's 10 or now it's 15 commandments on what to do and not to do on gravity regressions. And one of them is the use PPML, and that's kind of confirmed with your paper as well. So let me start with the quote that I like very much. And so this is Albert Einstein. It's about making everything as simple as possible. And I think that is also a good contribution by Ben's paper, that it's actually trying to make a complicated thing simple and useful for policymakers that are required to do rigorous tests and these kind of things. So the simplest possible way of doing these welfare analysis from trade, at least at the first look at it, is this paper by Arkolakis and co-authors in 2012. And here you can see the welfare effect is simply the change in the share of the change in welfare is determined by the change in the share of domestic goods and services in consumption and the trade elasticity. So very simple, and if you have the data and do an ex post analysis, you can kind of do a pretty easy to do analysis. But then the second part of Einstein's quote is it too simple? And here, of course, you can do a lot of unpacking, which I see Ben has done quite a bit of that. So even if we do it at an aggregate level, as Arkolakis and others, their first shot was, then you still need to estimate the trade elasticity, and you need to do that using gravity. And I don't see that as a problem, rather because there is no such thing as a gravity law in trade as you have in physics, that it's determined by some natural forces. And we also still need to estimate the part of domestic consumption that the change that was caused by the trade policy change. And that is also not straightforward. And that's what Ben has tried to do with his robustness checks and looking at the fixed effects versus the regressions where you have the counterfactuals. And we may still want to know the breakdown of the aggregate sector aggregate of the total. So if we unpack this very simple formula, it gets a bit complicated after all. And if we look at it at the top level, most of the time we find that trade policy and trade agreements do not have a very large effect. So let me go to the three questions that Ben asks in the paper in the beginning. So how realistic are the model's assumptions? Does it matter? The very quick answer is no, as long as the cat catches mouses, it doesn't matter whether it's black or white. So I'll get a bit back to that. And then I think it's a very nice distinction, and that is what policymakers want to know, and the kind of questions that economists and researchers have the tools to answer. So what would happen if all else equal, so as post evaluation? That's the kind of question that we can answer. And then what will happen? That's the kind of question that policymakers want to know. And it's also what happened is also something that the press sometimes write about. And then the third question is what degree of uncertainty attaches to model results. I would rather frame it as how robust are the results to changes. And we can look at robustness in model assumptions, which you don't do, and in parameters, which you do and find it very robust. So when it comes to the model assumptions, there are two schools of thought. So one is close to your statement here. So no, all that matters is predictive power, and you quote Friedman and also some other more philosophical papers. And then there is another school saying, yes, models should both have predicted power and build on plausible assumptions. And here you have a school which is based more on a very recent one, which is on complex systems and these kind of things, and looking at the economies as such. And I would argue, when does it matter? It matters much more during periods of structural change and when the model is used for ex ante impact assessment, because if you cannot expect that that the future looks about the same as the past, then it really does matter what assumptions you make. And also when policy variables interact with other model variables. So that also happens. For instance, you have often situations where the tariff would depend. So the elasticity with respect to a tariff will depend on distance, for instance. And these kind of things, then it does matter a bit. And if we go back to Arkolakis's paper with multiple sectors, and then he shows that with or without trade intermediate inputs, the welfare effect depends on the assumptions about the nature of competition, whether it's perfect or monopolistic. So this epsilon is actually adjusted with one or two more parameters. So that can actually be relatively easily done in your paper also to test for different assumptions on competition. And then just a few words about the predictive power of your paper. So the all else equal question you run with fixed effects. And then my question is, do exporter, importer, and sector fixed effects pick up all else or most of all else? Or is there a possibility that the counterfactuals, which are bilateral, pick up non-tariff related peer-specific factors? And that's also something that that you could check using only peer fixed effects. And then another question, which I'm sure you have thought about, but it's more about demonstrating a methodology than picking up these kind of things. But you have situations where anticipation, when phasing tariffs out or in, could have an effect in the short run. And what you see in the photo here is Chinese EV vehicles piling up at ports in anticipation of tariffs. And you also have these issues about investment in export capacity and establishing import or sourcing links that might take time. And then the question is also, are tariffs like other trade costs? So as I mentioned, elasticity may change with distance, for example. And yeah, here you have the classical literature on export versus FDI. So you may have a switch point where exporters prefer FDI instead of exports, and that would be kind of a non-linear relationship. And then you can also think about reducing tariffs from a high to a moderate level may be different from eliminating tariffs altogether, because you get rid of a lot of paperwork as well. So I don't think I'm going to talk much about this, but I just here, so I have three types of model. And the third one is also interesting going forward. So that's more like machine learning simulation using tons of data. They are very complex, so they really break with Einstein's idea. But since we have all this data and compute power, we could as well use it if it's useful. So let me just wrap up with answering the question that we started out with, both you and I. So I think these NQTMs are a substantial improvement on traditional CGs, particularly in terms of predicting power. They are flexible and they heed Einstein's advice. But I also think good CGs can be useful for revealing unintended and unexpected side effects of trade policy changes, even if we don't believe in the magnitudes of what they produce. It's sometimes an eye-opener for what could happen. And then I think also one challenge is really to communicate which questions the models of all types can answer versus what policymakers want answered. And here again, it's very both lobbyists and the press, they want numbers and they want big numbers and they want to blow it up in a head grabbing. So you probably all remember the estimates that the OECD made on the impact of the trade facilitation agreement, and people were running around and asking for the 75 billion that was estimated as gain. So these kind of things are very popular, but it's important to be clear about which question we can answer and which we cannot answer that precisely. And finally, modeling during periods of structural change is a challenge and a philosophical question to leave on the table. So how predictable are FDI outcomes really? Could it, for instance, be the case that it depends on the sequence of things? It depends on even which month of the year it was initiated. So these kind of questions are also interesting. Thank you.
Thanks for the.
That was.
Sorry.
No, go ahead, Ben.
Oh, I was just going to say thanks, Hildegunn, for the great comments. You know, as I said, this is work in progress, so I'm going to spend a bunch of time revising this. I'm going to take all of that in. I mean, your comments are always excellent. I found these ones sort of particularly useful, so I'm really grateful for the time that you put into that. One kind of reaction, you know, I thought about some of the questions that you were asking when I was putting the paper together. And one question I thought of, I love that you started the comments with the Archilochus paper, because, one question I had, I teach gravity modeling a lot, and I normally only teach the kind of single sector, no input output relationships, ignore tariff revenue, that kind of classic, very useful, but very, very simple model. And one question I often get from people doing the course is, how well does this match reality? Like, if it's a good predictor, do we need all the bells and whistles of all the more complex models? Again, getting back to this question that you asked about, if something catches mice, do we care which color it is? And I didn't do that in the paper. I used a multi-sector model that's got a few bells and whistles. There's tariff revenue, there's all that kind of stuff. Because I thought, well, this is the sort of model, when policymakers ask questions about things like trade agreements and tariff changes, normally they want to hear that there are things like input-output relationships across sectors. Now, my own view, I'm not a Friedmanite for a lot of things, but his view of economic models, I think I subscribe to completely. That, I'm going to be radical and say that we really shouldn't care at all about how realistic the assumptions of a model are. We should only care about whether or not it produces good predictions. That's a radical point of view that I can get away with in an economics seminar room and on a webinar. I know that I can't get away with that with policymakers. They're going to ask, do you have input-output relationships across sectors? No, you don't. Then I'm not interested. And that's something great that this new generation of trade models does. CGE models, they've known that those questions were important since the 1990s, and they've tried really hard to answer them. And so what the new generation models do is to try and keep that, to say that we're going to keep what's really good and useful about CGE, and we're going to take off some of the stuff. There's a whole bunch of margins and things in GTAP, non-tariff trade taxes. They were very common before the Uruguay round. Now they're really not very common. So why would we keep them in a model? Can't we just kind of shave that off, knowing that it's not a big deal in most countries? And so that's what the new generation models kind of try to do. So I really hear you on that. I'm going to think about whether or not I should be even more radical and say, look, I'm going to repeat the analysis with a single sector gravity model and see what maybe like a multi-sector but no input-output relationships, like basically just a combination of single sector models across all the different sectors with an income thing to tie it all together. So maybe I'll do that. That would be, if that turns out to be a good predictor as well, then I don't know. I mean, a lot of us have put a lot of time into more complex models, and if a simple one really does the job, it's great news for the barriers to entry in terms of getting into trade modeling. It's maybe not great news for those of us who've already sunk the cost in learning all the more complex stuff. But I think that's a really good question, and that's one that I'd like to go a little bit further with. I like the way that you thought about uncertainty. So to frame it as robustness rather than uncertainty, I'm going to go back and do that. And you're right that, there are at least two margins of robustness that we could be interested in. One is the assumptions and the other is parameters. I only do parameters. And, your point about assumptions is absolutely valid. There's the Costino and Rodriguez-Clare handbook chapter where they go through, the exact process that you mentioned of sort of saying, okay, we start with the Archilochus et al. Formula, then we add intermediate inputs, we add monopolistic competition, we add heterogeneous firms, and how does it change? And so that's a beautiful example to me of sort of analyzing how robust these sorts of findings are to changes in model assumptions. The reason why I didn't do that, it's a technical reason, but I'll share it. It all gets way more complicated if you try to account for the effects of tariff revenue. So in the Archilochus paper, and again in the Costino and Rodriguez-Clare paper, they assume that you take all the tariff revenue and you throw it in the ocean. Whereas in my model, I assume that it's recycled, consumers get it and they spend it. So that was why I stuck in that framework. But you're right, it would be possible to replicate this using all of the approaches in the Costino Rodriguez-Clare handbook chapter, which account for all of these different assumptions that you mentioned. I think that'd be a really valuable thing to do. I just have to figure out whether that's my valuable thing to do or whether it's someone else's valuable thing to do. How predictable are the effects of free trade agreements? That's a great question to kind of wrap up on. The short answer is I think we can actually do a lot to predict the effects of trade changes. This one-to-one correspondence that I find across about a third of sectors, I was hoping for that, if I'm honest, but I didn't really expect to find it. I thought I would find a statistically significant association, but it wouldn't be one-to-one. So I was kind of surprised by that. And I think it provides a bit of encouragement for that last question you asked about the effects of FTAs. So I'm quietly kind of optimistic about that. But you also asked a great question. Why do I do this over only 1 year? What about anticipation, investment, and all the rest? And the reason for doing it over 1 year is one is a practical reason, and the other is a little more philosophical. The practical one is that unless I go a long way back in time, if I try doing it over a 5-year horizon, I end up in the middle of COVID, and then I've got so much else, and that gets to your structural change point. If I was using the model to predict trade changes between 2019 and 2020, its performance would be horrible, obviously because of COVID. Now, I hope that my fixed effect would capture a lot of that sort of stuff, but I actually haven't tested that, and I'm suspicious that if I did that, it wouldn't be anywhere near as good for the reason that you pointed out very, very rightly. So that's a practical reason why I don't do it over a longer time frame. The philosophical one is that I sort of wanted to give an analysis of performance of the model in typical circumstances. So not something like NAFTA, which is this giant trade policy change involving one large and two medium-sized economies. I want to see what it does across small economies, large economies, big changes, small changes, and how it kind of all comes together for a global set of changes. So that was my rationale, and I'll have to write it up, to make clear why I've done that. I think it's a very fair question. All the other effects that you mentioned are definitely there. Let me take, Hannah, if it's okay with you, a couple of questions from the chat box. There's a question from Irene about comparing the results that I get from an NQTM, so a new quantitative trade model, what I'm calling a new generation model, and traditional CGE. Do I do that? No, I don't. The reason I don't do it is, firstly, that the Kehoe paper from 2007, Kehoe et al., which I cite in the paper and in the presentation, already does this using unconditional correlations. But the more banal, mundane reason is that I don't work with GTAP. You know, I've never gotten involved with GTAP. So I think there's a challenge out there. If you're a GTAP guy, go replicate this with the same data, your model, and let's see how it does. It could be that the richness of all the assumptions in GTAP is actually really useful. Maybe when you do the analysis, you find that 20 out of 35 sectors have a one-to-one relationship. And that'd be great. And that'd be a really strong piece of evidence for why we should keep using GTAP. If, on the other hand, performance is the same or worse, that's not so great for the richer assumptions. If you take this view that I take, that what matters is the predictive value. So if there are GTAP people out there, please go do this. I'd be really fascinated in the results. It's just not a set of results I can present myself. Then there was a nice question about GVCs from Sawan. Let me provide an answer to that. There's a version of the model that I use here that incorporates global value chains, where you can get changes in things like backward linkages, forward linkages, GVC participation, all these sorts of measures as an output of the model. I've published a paper using that version of the model. It's in World Economy from a couple of years ago. It's on the trade facilitation agreement. And the source model, because I obviously didn't make it up, is by two researchers, Eichler and Hyland. It's in the Journal of International Economics in 2018. And the paper is called Where is the Value Added? And they're looking specifically at the accession of China to the WTO. GVC participation obviously being a really big outcome of that. The question was specifically about FTAs. It's easy to adapt this to an FTA context. So that would be my suggestion. There are some nice models out there that look specifically at GVCs. So thanks again, Hildegunn, for the great comments. Thanks for the nice questions in chat. And Hannah, back to you.
I have one closing question before I let everybody go. Well, first of all, amazing seminar and great questions coming in, and so many people are like me, super interested in this topic. And I thought a little bit about, have you gotten those commercials on YouTube where people are like, do you know that you can learn hundreds of songs on guitar by just using 3 chords? This is sort of like the same thing, right? You can get very far and do it's an interesting thought experiment. But I have to ask you my always question, which is so we've nerded out a little bit here, and so there's plenty of meat here for those who want to take and run with this. But what is the main thing that policymakers should take from this? I love how you phrase the would and the will. It's sort of like, if you go to the gym, depends on if you keep eating what you're going to eat. Yeah. So how would you phrase that?
Yeah, I think there are two takeaways. I mean, to build on what Hildegunn said, it would be great if we could get the message across that trade models don't produce wills. I would love to get that across to policymakers. And frankly, I'm not going to win that battle. That's something that we've all got to start doing. It is made harder by the fact that many policymakers are more familiar with macro models than trade models. And of course, a lot of macro models do produce wills. They're based on forecasts. So getting that message across would be a really nice takeaway. That's a hard one. We've been trying to do that arguably for 30 years, and I'm not sure that we've really hit that nail on the head. But the simpler message that I'd love to get across is that if you're a policymaker and someone presents the results of a quantitative trade model, you've got to do better than saying, how realistic are the assumptions? If you don't incorporate my favorite assumptions, I'm not going to listen to the results. And asking the question of, well, I don't think this model fits with reality. It doesn't predict stuff very well, that sort of thing. Again, you've got to do a bit better than that now. So by all means, be skeptical of the results of trade models, ask questions. But I think what I'm trying to do with the paper is to put those sorts of questions to bed, to say, okay, we've got evidence that this does a pretty good job of predicting. Let's go on to the next question. So there's plenty of questions of policy interest that we can ask about quantitative trade models, both what they produce and also, what goes into them, how we do them, how we interpret them. And I'd like the spotlight to go more from the first set of questions and onto the second set of questions. So those are kind of my two takeaways.
Do you agree, Hildegunn? Very few people have your combination of policy making and like really deep research diving. Would you want to end on that same note?
So I fully agree with Ben on the take on assumptions when it comes to policy debate, because my experience is also, I can say it now, and I'm kind of out of the policy work, that what my take is, when policymakers really get picky on the assumptions is when they don't like the results.
Yeah, absolutely.
That it's not that they don't believe in the assumptions. So on that note, I fully agree. But I also think that we still need to think a bit about the assumption, if they matter for how generalized the results are, and they are kind of just specific to this particular question, that they do a good job in predicting power. Then I guess we need to think about what applies in the more general case, and also, does it matter going forward with structural changes? Do we need to do something on the theory base? So
yep, great points to finish on. I think you're muted, Hannah.
All right. Well, somebody has to do that. Somebody has to speak with. Yeah. So no, congrats. Yeah, you're welcome. I did it. David just suggested that the WTO could take that and run with it. So, and I'm right here, so maybe I'll just suggest that. Well, thank you so very, very much, Ben and Hannah, I guess, Hildegunn, Hannah, for coming today. Amazing insights as always. As we now close out, Ben, we have a really, really good next webinar coming up too.
We do. We're going to be talking about trade in electric vehicles on July 16th. So Michael Ferrantino is going to be our guest host and moderator, one of our board members. And we're going to have Michael Gasiorek from the University of Sussex speaking on that. So great policy question, very up to date, very current, very important. So if you're interested, please come and join us. So July 16th at 9 a.m. US Eastern Time.
Yes, yes. Have a great day, everybody. Thank you so much for coming in. Safe travels, Hildegunn.
Thanks, everyone.
Bye.
Bye.